Dear students, today we'll start a new topic, work, power, energy. Now, to understand work, what we usually means is quite different in physics. Now, if you sit the whole night studying in a table, then you will be saying that you have done a lot of work. But in physics, that is not a work. Now, physics, as you have studied in school, work basically means when a force causes a displacement to a body and the component of the force is along the direction of the body, that is called work. Now, to understand work, we must go a little back and understand vectors. First of all, we must understand what is called a dot product. Now, dot product means multiplication of vectors. If you have two vectors, A bar and B bar, and if you multiply them, if you multiply A bar with B bar, then you write A bar dot B bar. Write it like this, A bar dot B bar. So that is called a multiplication of vectors. Now, according to the definition of dot product, A bar dot B bar is equal to mod A bar into mod B bar into cosine of the angle between them. Cosine of the angle between them. The angle between A bar and B bar is theta. So, A bar dot B bar is mod A bar into mod B bar into cos theta. Now you see, this is a magnitude and this is also a magnitude. And this angle is also a magnitude. So, if you multiply two vectors A bar dot B bar and the answer is a scalar, then we call it a dot product. If you multiply two vectors, say A bar and B bar, and the answer is a vector, then we call it cross product, and we write it like this, A bar cross B bar. So A bar dot B bar is scalar and A bar cross B bar is vector. So what we'll be using in defining work. So understand that if you multiply two vectors, if the answer is a scalar quantity, then it is called a dot product. For example, if we multiply one force, if we multiply force as a vector and displacement is also a vector, dot product F bar dot S bar, and we get it as W, and W is work or a scalar quantity. So work is a dot product of force and displacement. So this is one thing you should know. Another thing that we should know is called the resolution of vectors. How to resolve a vector? You have a vector, say R bar. The R bar is resolved into two components, Rx and Ry. You see, Rx is along the x component and Ry is along the y component. So we can resolve a vector along two components, x component and y component. The x component is called Rx. So if you write Rx, the x component is Rx. How much is Rx? Rx is, from the diagram, it is OB. It is OB. So what we can write OB, this is equal to, how much we can write it as? We can write it as OB by OC into OC. It's OB by OC into OC. So if you cancel this and this, you get OB only. So what is this equal to? OB by OC. OB by OC is your cos theta, because R is making an angle theta. So cos theta is OB by OC into OC. What is OC? OC is your R. So Rx is equal to R cos theta. Similarly, if you write Ry, say Ry, this is Ry. So Ry is equal to how much? It is equal to OA. How we can write it as? We can write it as OA divided by OC into OC. So OC will get cancelled. So how much is Ry? Ry is how much is OC? OC is your R. And how much is OA by OC? OA by OC. So this, remember, OC is the hypotenuse. So this is equal to how much? This is equal to sin theta. So Rx along the x-axis is R cos theta, and Ry along the y-axis is equal to R sin theta. So these two things we must know. So this is all about resolution of vectors. Now let us find out the definition of water and see. Let us consider an object placed at the point A. Now this object is pulled by a force, F. Now this F force is resolved into two components. One along the x-axis, this is F cos theta, and one along the y-axis, and this is F sin theta. Now this force F sin theta is acting vertically, and F cos theta is acting horizontally. Now the body gets displaced from A to B. If the body gets displaced from A to B by distance S, then what is done? How much is the work done? The work done W is equal to F cos theta into S. Remember, work is equal to force into displacement. Now, this body is moved from A to B by F cos theta, not by F sin theta. F sin theta will take the body upward. F cos theta will drag the body along the horizontal. So if you move from A to B by distance S, F cos theta is responsible for displacement. So work done is F cos theta into S. Or we can write W is equal to F S cos theta, or W is equal to mod F into mod S into cos theta. This is the magnitude, and this is the cosine of the angle between them. And just now I told you this is nothing but dot product of force and displacement. So work done is a scalar quantity, and it is equal to the dot product of force and displacement. This is all about the dot product of force and displacement. So whenever we define work, we now say that work is nothing but the dot product of force and displacement. Now let us take some cases. We know that W equals to Fs cos theta. Just writing F and S indicates this magnitude. So this is, say, we just understood that W is equal to Fs cos theta. Now what is theta? Theta is the angle between force and here the displacement. Displacement along the x-axis and force. So force and displacement, the angle is theta. or cos theta. Now, let us take few cases. The case 1 is case 1. What happens when theta is equal to 0 degree? Now, when theta is equal to 0 degree, then W is equal to Fs cos 0. So, the angle between F and S is now 0. That means force and displacement are in the same direction. This is the direction of force, this is the displacement. So, here the angle is 0. What we get, W is equal to F into S. This is called positive work. This is called positive work. So, when work is equal to force in the displacement F into S, positive, this is positive work. So, what is positive work? What are the examples of positive work? Say, an engine is pulling a train. The engine is moving in this direction, and the train, that is the compartments, are moving along the same direction. That is an example of positive work. Now, let me give you another example of positive work. Suppose you have a ball and you drop it. If you drop the ball, then gravitational force is in the downward direction. When gravitational force in the downward direction, displacement is also in the downward direction. That is an example of positive work. So, positive work means force and the displacement are in the same direction. Now, let us see what happens when theta is equal to 180 degree. Theta 180 degree means force and displacement are in opposite direction. You have a force this way and a displacement this way. So, angle between force and displacement is 180. So, when theta is equal to 180 degree, W equals to F S cos 180 degree, or W is equal to minus Fs. Remember, cos 180 degree is minus 1. So, W equals to minus F. This is called negative work. So, this is called a negative work. Now, what is a negative work? A negative work is a work when force and displacement are in the opposite direction. Now, let me give you some example of negative work. If you take a ball and you throw it upward, you take a ball and you throw it upward. This is the applied force. Remember, gravitational force is downward direction. So, when you throw the ball upward, what happens? When you throw the ball upward, then with this is x is the displacement. So, when you throw the ball upward, gravitational force in the downward direction. Force downward, displacement upward. So, with gravitational force, the work done is negative. And with applied force, the work done is positive. Gravitational force, downward direction. Displacement, upward direction. Angle between them is 180 degree. That is an example of negative work. But with applied force, if you apply the force upward, then force also upward, displacement force also upward, displacement, remember, is vector quantity, is also upward. So that is example of positive work, and with gravitational force, it is negative work. Another good example of negative work is swimming. When you swim, you push the water backward. So, when you swim, you push the water backward. So, these are the water. What happens? The man, so this is a man, okay, is swimming. This man moves in the forward direction, and the water will move in the backward direction. So, he applies the force backward. He applies the force backward and the man moves forward. That is an example of negative work. So, we have understood positive work and negative work. Now, one more thing that is to be understood is what happens when theta is equal to 90 degree. That means displacement and force are perpendicular. That means this is the direction of displacement and this is the direction of force. The angle between them is 90 degree. What happens then? Then W is equal to Fs, then cos 90 degree. And how much is cos 90 degree? It is 0. And it is called 0 watt. So, what is 0 watt? 0 watt happens when force and displacement are at an angle of 90 degree. Then we get 0 watt. A very good example of 0 watt is that you learned in school. A man carried a box in his head. This is a man, okay, and he carries a box in his head, okay, and he moves in the forward direction. So this is the displacement. And the gravitational force of man is in the downward direction. Angle between them is 90 degree. So this is an example of 0 watt. Another very good example of 0 watt is, let me show you, this is very important. Another very good example of 0 watt is, now say this is the earth or the sun, and you have a satellite revolving around it. This is a satellite revolving around it. So remember, this satellite and the earth is having a gravitational force of attraction. Gravitational force of attraction between the satellite and the earth. Now, when the satellite moves in a direction, say like this, that is in the clockwise direction, at any point displacement is given by the tangent. So if it is here, the displacement is in this direction. This is the vector displacement. So you just draw a tangent. So this is the force, this is the displacement. The angle between them is 90 degree, and work done is equal to Fs cos 90 degree, and that is 0 or 0 watt. Now, this F is usually known as centripetal force. Centripetal force. So we say work done by a centripetal force acting on a satellite around the earth or earth around the sun is 0 watt. That is, work done in that case is 0. So we don't need any fuel to revolve the satellite around the earth because work done is 0. So what we have learned is that there are 3 kinds of work: positive work, negative work, and lastly 0 work. So there are 3 kinds of work. Now, one small things about work is, that is dimension of work. What will be the dimension of work? Work is equal to force into displacement, or work, because what is the dimension of work? Force is m1, l1 and t minus 2 into displacement is l. L is displacement. So work done is equal to how much? Is m1, l squared and t minus 2. That is the dimension of work. And you know the units of work are the units of work are, number 1, in CDS system. In CDS system we call it ergs. So what is 1 erg? So work is equal to, or work is equal to force. Force will be in 1 dyne. into displacement is 1 centimeter. So this is equal to 1 arc. So what is 1 arc? What is 1 arc of work? When a force of 1 die causes a displacement of 1 centimeter, it is called 1 arc. And number 2, the SI unit. SI unit is 1 joule. And 1 joule is equal to 1, instead of dying now, is 1 Newton into 1 meter. So what is 1 joule of work? When a force of 1 Newton causes a displacement of body by 1 meter, we call it 1 joule. So two basic units of work, CGS unit and SI unit, arcs and joules. Okay, so arcs and joules. So this is a little bit of introduction of work. In subsequent, we will see what is the definition of power and energy, and then we mix everything and understand. So for the first class, thank you very much.